Welcome to this session. In this session, I am going to talk about Western standard cadmium cell. Standard cell, a cell which is capable of giving constant and reproducible EMF and has a negligible temperature coefficient of the EMF, that is called as a standard cell. So, a cell to act as a standard cell, it should satisfy three conditions. The three conditions are: the cell should produce a constant EMF. While using the cell all the time, it should produce a constant EMF. That is one condition. Second condition is the cell should produce a reproducible EMF. While we use the cell for many times, under identical conditions, it should produce the same EMF. This is the second condition. And the third condition is the cell should have negligible temperature coefficient of the EMF. As the temperature changes, the change of EMF should be low. These are the three conditions for a cell to become a standard cell. Western standard cell is an example for a standard cell. Western standard cell was invented by Edward Weston in the year 1893. From 1911 to 1990, Western standard cell that was adopted as the international standard for EMF. From 1990 onwards, Joseph voltage standard is used as the international standard for EMF. Now, let's have a look at the Western standard cadmium cell. We start with the construction of Western standard cadmium cell. It consists of a H-shaped glass vessel. This is the H-shaped glass vessel and the lower ends of both arms. So this is one lower end and this is the another lower end of both the arms. These two are closed and these are sealed with platinum wire. You can see here, this is the platinum wire from this end. This is the another platinum wire which is used for connecting, and we have here two electrodes. This is a negative electrode and this is a positive electrode. The positive electrode contains mercury, and over this mercury we have a paste made with mercurous sulfate and mercury. This is mercurous sulfate and this is mercury. So this is the composition of the positive electrode in the Western cadmium cell. And coming to the negative electrode, this is the negative electrode and it contains an amalgam of cadmium. This amalgam contains 12 to 15% of cadmium. The remaining part is mercury. And over both electrodes, this is a negative electrode, this is a positive electrode. Over both the electrodes, some crystals of solid cadmium sulfate are sprinkled so that the electrolyte will be saturated at all temperatures. The electrolyte here is cadmium sulfate solution. The upper ends of the Western cadmium cell, they are sealed with corks and sealing wax. This is about the construction of Western standard cadmium cell, and it can be represented as cadmium, mercury, cadmium sulfate, then we have salt bridge, then electrolyte, cadmium sulfate, then mercurous sulfate and mercury. At the anode, amalgam of cadmium undergoes oxidation producing Cd plus 2 plus 2 electrons plus Hg. At the cathode, we have mercurous sulfate, Hg2SO4. It undergoes reduction by consuming the 2 electrons, producing sulfate ion SO4 2 minus plus 2 Hg. The overall reaction is cadmium, which is a solid, plus mercurous sulfate Hg2SO4, which is also a solid, gives rise to cadmium sulfate, which is a solid, plus 2 Hg. This is the overall reaction in Western standard cadmium cell, and this cell produces a potential of 1.018 volts at 20 degree centigrade temperature, and this cell works for many years at a stretch without any voltage changes. That means it produces a constant EMF. Two forms of Western standard cell are available. They are saturated Western standard cell, unsaturated Western standard cell. This division is based on the saturation of the electrolyte, that is the cadmium sulfate. The saturated Western standard cell, that is most permanent, as it is not portable and it has a large temperature coefficient. It is typically used for accurate works like calibration of voltmeters. While using this saturated Western standard cell, the temperature must be controlled. Second one is unsaturated Western standard cell. This is the most common Western standard cell. This is a portable one. The electrode material and mercurous sulfate present in the unsaturated Western standard cell, they are held firmly in place with porous plugs so that even the cell is inverted, no damage can be incurred. The temperature coefficient of unsaturated Western standard cell, that is negligible in most applications. The main difference between the saturated Western standard cell and unsaturated Western standard cell is saturation of the electrolyte, and another difference is the saturated Western cell that has a large temperature coefficient, whereas unsaturated Western standard cell, the temperature coefficient is negligible. The nominal voltage for saturated cell is 1.0186 volts, while for the unsaturated one, the voltage is 1.019 volts. Advantages and disadvantages of a Western cell. Greatest advantage of Western standard cell is very small change in EMF with the change of temperature. As the temperature changes, the change of EMF is very low for this Western standard cell. Saturated Western standard cells, they have greatest voltage stability over the time, and their thermal stability is very low. So saturated standard cells, even though they have greatest voltage stability, they are thermally unstable. So we have to control the temperature while using the saturated Western standard cells. In case of unsaturated Western cells, thermal stability is high compared to saturated Western standard cells, and these cells are best used in temperature controlled conditions. The main disadvantage of Western cells is their intolerance to current drain. So the Western cells, they should not be used with analog voltmeters. If used, they lead to wrong results. Important applications of Western standard cells are: these are used by national laboratories to standardize the value of volt, and these cells are also used as laboratory standards for calibration of voltmeters. This is about the Western standard cadmium cell.